on the reservoir. Then properties. So properties कुठे properties मला इथे हां 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 इथे अच्छा अच्छा
ड्रॅग करा माउस पॅड
हां ते माउस पॅड ते ओपन नाही हां this is the property pane. Then under physical, I will assign the elevation as given elevation is 340 meter. Then for pump, we have to give elevation which is given as 340 meter. Then pump definition. In pump definition, edit pump definition. Then here I will have to say as new pump definition. Then the instead of standard 3 point, I will click here design point 1. Then the pump discharge is given in MLD, so I will have to convert units and formatting. Instead of liter per second, it is in MLD. Display precision 0 is okay. Okay. Demand is given as 30 MLD and head is given as 24 meter. Then enter. This graph will appear. Close this window. And here in pump definition, I will enter the pump definition 1. So as far as pump is over, then tank. For tank, elevation base is given as 360. Then elevation minimum is 360.5. Initial elevation is given as 361 meter. Maximum elevation is given as 366 meter. Then ground level at tank is 340 meter. Then diameter is circular shape, diameter is given as 15 meter. So tank is over. Then this is intermediate node without demand. So I will give only the elevation which is 310 meter. In J2 there is elevation of 315 meter. In J5 it is given as 265. For J4 it is 280. This intermediate node it is 300. Then I have to give demand to these nodes. I will click on demand node J1 and here it is demand collection. So I will click on ellipses. The demand is given in liter per second. I will convert it into million liter per day as it is given in MLD. Display precision 2. Then here you can enter the demand. It is given for J2 it is 10 MLD and then fixed pattern. Then another demand node demand is 5 MLD. Then for J4 demand is 15 MLD. Demand is given. Now the data of pipe is to be given only. This is the pipe 1. So diameter it is given at 600 mm. C value I will change afterwards. Has it is false, so I will make it as true. So I can enter the user defined length. User defined length, first length is 10 meter. Then for pipe 2, diameter is 600 mm and user defined length is 1 kilometer. Then for pipe P4, diameter true and length is 20 kilometer. Then for P5, diameter is 400 mm and length is 1 kilometer. True. Then you define length is 1 kilometer. Then for P6, diameter is 600 and length is 2 kilometer, 25 kilometer. Now all the data is given to model, only C value is yet to be corrected. So I will select all the network, then view and flex table. I will open the flex table of pipe, and here C value is 130. I want to make it 140, so I will make it as global edit and enter the new value of 140. So it is okay. New value is entered. Then under analysis, I will validate the model. No problems were found, so I will compute it. And we will see the results. We wanted to analyze the model, so we will see the junction results. Here the pressure is given in kPa, so I will make it as meter H2O. It's okay. And at J4 I have not entered the elevation, so I will select it J4. The elevation is 280. Now again I will calculate, compute the model, and we'll check the flex table and results of junction. So we can see here that the 5 meter pressure is critical. I want to locate where this node is. So I will select this node and show on drawing. So this is the critical node. Likewise, we can see the properties of all the hydraulic elements. Now we will view the profile. In profile, I have to select new, then select from drawing. I will select this source, tank, and this critical node, and open the profile. So this is the profile. This yellow line shows us ground elevation and shows a hydraulic gradient line. Thank you.
Madam has just created one simple hydraulic model. But let me tell you about this very simple model wherein we have to work out what is the frictional head loss using the Hazen-Williams formula. I want to validate whether the results the model is giving correctly or not. So for that purpose, this again a small model of say 100 meter, 91 MLD. This model we will create and run. So this I will be. Now we want to create this very small model. So first of all, you have to see in layout all these different elements are given. So first is the reservoir, then you have to add pipe to it. So pipe we are adding, and one simple node we have to say like this. Then the elevation of this tank is suppose 100. In that example it is mentioned as 100. Then the elevation of this junction node is 90. Now what is the difference between the common node and the junction node? Junction node is a node where the demand is taken out. So like your service reservoir, from service reservoir water is supplied. So it is called as a junction node. So all the supply nodes will be called as the junction node. And here, as madam told, this demand is in MLD, 1 MLD, then its pipe length is she has used this user defined length. I will show you later on how this our GIS base, when we use GIS base, this type of the data need not be given. But we have given this now, and I am running this model now. Model is run, and here if we want to show the attributes, now there is a facility. We will have to select this and say new annotation. In annotation we have to see head loss, frictional head loss, and I am saying it, show it to me at -2 is a coordinate, and this one. See, it is 3.21 is a frictional head loss. Now if you can see why it is so 150 I have not given diameter. So diameter is 150. Now you have to run it. See, it is 3.41. Now still you can see it's 3.47, and here it is also 3.47. If I increase the number of your decimal points, it will exactly show. The point is, with Hazen-Williams formula, it is giving 3.46, and in our WaterGEMS also it is giving 3.47. That means it is confirmed that the software is behaving correctly. So another example which I wanted to show is that this is a small network, and with manual calculations with this Newton-Raphson method. Newton-Raphson method is shown over here. We have to first of all assume certain heads and carry out this process of repetition and find out this correction. So after this all the corrections, with manual calculation, the HGL value, and with WaterGEMS it is 99.8. That means the software is behaving correctly and we can trust the model software. Now the next step is how can we create the GIS-based hydraulic model. So far non-GIS software was, you have seen, one which created by the madam. Now we will be developing the hydraulic model using the Shapefile which we have created for Rana Pratap Nagar, if you are remembering that one. So we will try to do that, and for that purpose for making this hydraulic model, either you have to have GIS data and then networks of software, you can create this. But if the data is only in a hard copy, then you have to manually draw the pipeline which madam has done. Otherwise, to geo-reference it, and then using the shapefile, you can still create the hydraulic model. Sometimes, so 3 cases occurs. One is the drawing manually sketch and it is like this rubbish drawing. Such sketches are there. Second case is you don't have that map also. So in case of Ayodhya, we did this design. No data was available to us, but still there is a way to create the network. How we can do that? If you know the center line of your road, we can still create the hydraulic model. And this road center line can be created. There is a free software called as OpenStreetMap. Using this OpenStreetMap, you can have the center line of any road on earth. So this is also free, where there is a group of people and everybody is contributing to new area, and it is added and then it is available to rest of the world. So with using this OpenStreetMap, in case of the Ayodhya, we could find out the road center line and then we prepared this hydraulic model. So the steps of this model creation in WaterGEMS is, first of all, using the ModelBuilder, using the shapefile of pipe, tanks, walls, pumps. We have to create the model and then give the attributes and then run it. Attributes also using the GIS. How can we do that? We will see now. So in case of Rana Pratap Nagar, the steps I mentioned is open the WaterGEMS, create new project, set units to SI. This we will be doing. And using the shapefile which we earlier created, define the projection system as this one, start ModelBuilder, assign the diameter to both your model as well as GIS data, and then we have to create this model. How the steps I will show you. In this way we created the network for Nagpur. Work of Bhagalpur, those in tender quantities only 30 kilometers was taken, but no GIS. Then we carried out GIS and I said that the length of your network is 50 meters. Everybody attacked me. You are wrong, you are wrong. Then I said, Mr. Gentleman, take your vehicle and measure it actually. It was 50 kilometers. So GIS never makes mistake. GIS is very accurate.
Not about GIS, sir. Whatever the calculations you are making in WaterGEMS.
Yes.
The residual pressure at the ends or the load point.
Ah.
And on actual ground, if you are modeling this for this activity, you might have
See, yes, I got your point. I got your point. Now, you have to calibrate your model for that purpose. And if you calibrate, then your field results as well as design results must synchronize. So calibration is required, and there are methods of making the calibration which is out of scope of this course. But I will tell you, with digital twin, when we fed the actual sensors data, which is actual, then the digital twin automatically makes the calibration, and then our whatever we observed in field, observed in our model exactly tallies with your field readings. That he has done it.
There might be some other variables also we cannot in our model.
Sir, calibration takes care of everything. Calibrations can be in two ways. It manipulates the C value and calibration is done. Another way is the cross-sectional area is also there. So you have to mention it, and then after calibration, those must show the same readings. Otherwise, it has got no meaning. Till now in India, people are not doing the calibration. Therefore, this hydraulic modeling is used only for the sake of the purpose of deciding the pipe diameters only. But as you rightly told, after your calibration is needed, and that's why tomorrow we are going to show you in digital twin with sensor data, because this, how it can be done, it must calibrate with your field data. Your model must be synchronized with that one, then only it will show. So there are other methods also without digital twin also you can calibrate. So that is called as the calibration, and Darwin calibrator is there. So, but without it also, using this, I repeatedly telling you, this once we give the field data of sensor, if your sensor is wrong, faulty, then it will show different answer. But if your sensor is also calibrated, then it will give the field data to the model, and then model and your field data must match.
But many times we don't have this kind of facility. Normally, most of the values, even the discharge distance to my garage. Many times discharge distance to adjust to believe that whatever assumptions have been made in the WaterGEMS software, which are like replicating the ground situation. So what is your experience? How far it is, like how much match, 80%, 70%, what is
It is 100% as far as your sizing is concerned. Sizing we do using the modeling, not analyzing and checking this, tallying with the reading. But for the design purpose, now, your network, how the pipe size is worked out, pipe is designed for the ultimate stage demand multiplied by your peak factor. And then using the steady state method, the pipe size is worked out. And that is the largest or the largest size. That means it is suitable for you. Now the question comes, if that level is changing, it will show different levels. But for the sake of your design of, क्या हो गया? Hello? But for the purpose of your design, the correct size has to be worked out, and correct size is worked out on this. So whatever this model, I am again telling you, hydraulic model we have to use for design purpose, or your what should be the size in your design. But as he said, whether for comparing the readings, calibration is required. So for example, if there is some low pressure zones in your city, and your model is showing differently and your model is showing differently, you have to calibrate it, and calibration of the model is a must for it.
Sir, like the factors like temperature and this has been also taken
Temperature
care by
will change only viscosity.
Yes.
Viscosity, insignificant factor.
Okay,
Insignificant factor. Let me show all this, first of all, how this model is created.
I am from PCMC, junior engineer. Yes.
Sir, we will discuss later on.
Okay, sir. Okay, sir.
I was associated with your work. You may be knowing or may not be knowing. So your first DPR was prepared by me.
Yes, sir.
So let me now tell you how this model is created from your GIS data. Then how the DMAs are created, how you are going to run it. Everything I am going to show you, and then you ask me any question. First of all, let me show this. I will discard this and I will prepare a new. I will close this. This is an untitled file, blank. First of all, what I will do, I will be saving it at some folder. So in this, what I am showing is, I will be creating another folder called as Nagpur 2. Here, I want to store my hydraulic model. Again, there are number of files are created, and if I want to make the revision, so I will say it is the original or number 1. So here, this Nagpur, Rana Pratap Nagar is a zone I want to create. So this model, first of all, before doing anything, you have to save it in different folder. Now the next step which madam has told is, first of all, make it a rule. Rule number 8, your units. While preparing the hydraulic model of Badlapur and Ambernath, I was just novice and new learner. So our unit was in FPS. So after so many efforts we took, still the model was wrong because of this silly mistake. So since then, I made a rule, before touching further, we must check the units of your hydraulic models correctly. So you have to go here, tools, then in tools, drawing. Now here is a unit. Here, this SI unit should be given. Wrongly in that case, US Customary, this FPS system was given, and the whole model was in vain there. So here SI unit means meter, kilometer, etc. So now unit has been given correctly. Now the next step is, you have to create the model using the model creator. What is your data in your hand? Shapefile of the pipe only at present. And I shown you the shapefile how you are going to create for Nagpur. So that I already demonstrated you in morning session. So I will create the model right from your shapefile. So for that purpose, let me first check my shapefile of the pipe. And before that also, we can attach our shapefile as a backdrop drawing of your model. How can we do that? Here you have to go background layer, then go to new file, then go here in Nagpur. I already created this road edges. Where is it? Under shape, road. So this road shape file we are already there, and it is not seen. So go to view and zoom to the extent. So these are the, are you able to see roads which our surveyor has done. If you don't have data, I already said, using the your OpenStreetMap, you take the center line and then give the buffer of 6 meters on each side, so that we will get this type of the road, 12 meter width or road. Once you get this, now you have to create the model, hydraulic model, pipe network on this map. How you are going to do? Here is a facility called as ModelBuilder. So ModelBuilder, I have clicked. Then I am saying new. Now here it's asking. You can create right from different methods, but I always prepare this shapefile. Then you have to mention the shapefile. For that purpose, here is a select your data source. I am selecting it. It is already done by me. So means in morning session I demonstrated how the shapefile is created for the pipes. So this pipe shapefile I have clicked, and you can see it's see everything is there, length, etc. Everything is there. So say next, then say meter, then say establish connectivity, yes, then say next, then say next, then again say next. Now here is a important step. Now here it is your GIS attributes of GIS, and here will be property in your hydraulic model. Both things must synchronize. So the diameter which is available in your shapefile must go in your hydraulic model. So what we will do, before that, this key field we have always say label. Then this D, and in our hydraulic model it must correspond with your diameter. Now next step is the material. Here material from your shapefile must correspond with your model material. And then it is enough. I don't require length because my lengths are accurate, and with GIS has done this job accurately. So I will not invoke these lengths. Lengths are not required by me because automatically it will come. So with these two attributes, I made correspondence between shapefile and my model attributes. Now I will say next, then finish, then say yes, and your model is ready from your shapefile. See, these are the nodes created and the pipe is there. Node is created at the end or at the T where this junction is there. So node is defined as a junction between two lines, T junction, or at the end. So these nodes are automatically created. Now if you don't want this backdrop shapefile, you remove it. Now this is the network of Rana Pratap Nagar. Now you have to first of all see whether your reservoir or your service reservoir is there or not. So it is unfortunately not shown here. So I will first of all remove all these labels of Now you can see I created this from your pipe shape file. This model has been created. Now here this service tank is there. We have to plan. Here unfortunately there is this pipe is not being shown. So what I will do, there is a facility in WaterGEMS. You have to right click and say reconnect. So it is reconnecting here and this node is now redundant. Now here, if I want to place the service tank, which we will be taking as layout, then the reservoir and reservoir. Now madam has already told what is the difference between the reservoir and the tank. Now reservoir is defined as an infinitesimal source. Means your source itself is infinitesimal. And if your source is infinite, your treatment plant is also getting continuous water. In that case, we can show as a reservoir. But there is a peculiarity. This reservoir and your tank in your steady state method. Now again there is a difference. Tank in steady state method behaves like your infinitesimal source. So we are always representing this tank as a reservoir in our zone. Now first of all, let us give the now ground elevations. And I told you it has to be given from the contours. So the contours are there. I will show you contours. New file. This is also readily prepared for our purpose. Contours are there. You can see the contours. Now these contours, as I told you earlier, with your total station or 3D stereo pair or drone, you have to create these contours. And these contours are created. I can change the color of this. It is very faint. Now these are the contours. From contours now, all the nodes must get the ground elevations. And there is a facility in WaterGEMS called as TRex or Terrain Extractor. Using this facility, we can assign the level data from your contours to the nodes of your distribution network. How we do that? So here is a tools and here is a TRex. You see, is a terrain extractor. We have to click it. It's very easy, only mechanical, it is a mechanical work. Anybody can do it with only some practice. Now the data source is this ESRI Shapefile. Why ESRI? ESRI is a company who invented this shapefile. So that's why this prefix is, they call it as a ESR shapefiles. Then elevation data sheet. Now you have to give the name of your shapefile here. So it is RPN Contour 1 shapefile, which is also there in backdrop. Now select this elevation field. It is elevation. Our units are meter. So we are giving in meter. And for all the nodes we have to give. If it is certain nodes are selected, then you have to say selection. Or if certain selection set is created, then we have to say selection set. But in this particular case, we want for all the nodes to be given this ground elevation. So I'm saying yes, and it has given within fraction all these. So now that's what I was telling you. If you say right click, now here is one facility. You have to select right click and say edit data and edit junction. Means all the junction will be selected and its attribute will be shown. Edit group, I am saying junction table. Madam has told you about FlexTable. So these elevations you will see. Elevations from the contours are assigned to each and every node. Now imagine that again. Now it itself is about 430 nodes. Imagine 25,000 nodes are there in your one zone and 1.5 lakhs nodes in your Ahmedabad case or your Chennai case. In that case, is it possible to give this level manually? How quickly within fraction of second it has given once it is Shapefile is there. This is the biggest advantage of this giving data by your GIS. Using GIS only we could do this. So now next part is we have to give the demand. Now what is meant by demand? Let me first go here. Water demand is, suppose there is a house comprising of 5 people and 135 is your norm. So we must supply 675 liters at their doorstep. There will be losses before that. So we have to add 15% losses to this and then give the demand to this node. So this is a node and this node must supply about 675 liter to this home. So for this purpose, now what we do, what this WaterGEMS does is that first of all it creates a Thiessen polygon around all the nodes. What is meant by Thiessen polygon? Thiessen polygon is a polygon which is constructed around each and every node. And this side is a perpendicular bisector of two adjoining nodes. For example, here these are the two nodes. These are the two nodes. Am I correct? And then that is a perpendicular bisector. Aega? You can see here, there are two nodes and perpendicular bisector is this line. So these polygons, each line is a perpendicular bisector of the two adjoining nodes, and WaterGEMS does this automatically for you. And then this is, you know, breakup of this 135. And now how it transfer this demand. First of all, in your WaterGEMS, you have to create these ward boundaries. Now you know the ward boundaries, you know the ward population. Now the ward population of 2011 census. Then suppose your base year is 2025. Immediate means after 15 years it is 2040 and ultimate is 2015. I was talking about this. See, that is the perpendicular sector of the two nodes. Now, using this ward population and population density of these wards, this is a ward boundary and this is a Thiessen polygon. So it interpolates and and you know the ward population density, so you know the population density and you know the people residing in that this Thiessen polygon. So you know the demand of that node, and you will see that suppose this how it can be done, it's a latter part which I will show you later on. So in this polygon there may be houses, then your offices, residential buildings also. And with respect to this CPHU manual, we give this. And then what to the Thiessen polygon to the node. In this way, this demand is transferred. This I will talk later on, but that also I have to show. Then I will, on our model, how it is done, that I will show you. Now this is very important part. And nothing was available in previous manual. We call, now again, there are different nodes. Before going there, let us discuss this. Different demands, fire, then your floating, residential, institutional, etc. And we, in our this manual, these commercial demands are there, institutional demands are there. And now this is a new thing which we added. In your old manual, this was not discussed. How you are going to account the demand of such small commercial entities, which is very difficult to measure. So what we mention in our manual is that you have to take their demand between 5 to 10% of the immediate demand of residential. In this way we have to account it. And this demand, hotel, lodges, hospitals, they are the big concentrated loads. So you must have this consumer survey for this. Now consumer survey, these are in few thousands only, it is very easily possible. But what another method which we have devised is that on your Google Earth, you say hospitals in Nagpur. It will show tuck, all the hospitals. You create a shapefile of it. From your Google, shapefile is of all the hospitals is created. So without, and you have to go there, those hospitals, and just ask how many beds are there. You have to take that information only, and your GIS spots are already there. Using the Google, you can find it out. So you are, in this way, these commercial demands are to be computed using your consumer survey of non-domestic. And then another important thing which nobody is doing. Now see, suppose this is a hospital, school, etc. It is here somewhere, here. But are you going to lay the pipeline here? Actually it is done. But if it is done, it will be large number of the nodes in your model, which is not expected. That's why we say that the concept of primary network. Primary network means we will consider only 100 mm and above. But below 100, it will be tertiary network. And this can be done. How? Now the load of this must go to this pipe and this node. How it can be done? Actually, you have to do this manually. It will take only half an hour or 1 hour if the city is big one. Now you carefully see. Now, this we have shifted to here. This manual work you have to do. Nobody is doing. These Ayodhya people, when they came to our office and then they said, how you are going to account? I said, we are already doing this. And this node we have shifted. And it is now in the form of node, and it is in the form of concentrated load. So whatever the water it has to supply, considering that node only. So in this way, these commercial and the concentrated loads we are taking care of. Now, I was discussing about this. So this ground elevation I have shown. Now I will be showing you how this is done. So we have to do this using the my eyes are weak, so it is here. Now, what you do for this? First of all, you have this watt boundaries GIS layer, and you have this census data of those watts. So for medium-sized cities also, all this data, census data is available. So say about 2011 data is available. You have to find out the population forecast of this watt. Then only using another method we can allot this data. But first of all, now once you have this watt boundary, then you must have these land use polygons. Very important. And land use polygons, you have to collect the CDP. City development plan. Every city has got a city development plan. You have to go to planning department of your corporation and take it. Those maps will be there. Now those maps will have to be, unfortunately you will get it in a hard paper copy only. You will have to scan it. You will have to make the JPG file. And then geo-reference it, which I have shown it to you. Once it is geo-reference, now you will have these polygons like this: commercial, institutional, open spaces, public space, water bodies, residential, etc. Now your work is not finished yet. Now this method we have inserted in chapter 2 of the new manual. And the detailed example is given in the appendix of chapter 2 in your new manual. So for that method, now our aim is how to find out the demand, future demand of watt. And different consultants are using different methods. So in order to make the uniformity, we created this method called as area reduction method. Then how it is done? So now on this map, your this ward boundary are to be there. Now there is one your facility in GIS called as intersection. With intersection of ward boundary and land use pattern, you will be, it's not difficult at all, not difficult at all. So you will be finding the commercial, industrial, institutional polygons of each and every ward. This we did for Nagpur also. It's a simple process, but some efforts are required. So these two files, shape files, we have to add in your model, and then with intersection command, now you will see that one. This is ward boundary, this is land use polygons, and that is your ward-wise land use polygons, ward-wise. Earlier it was not done, nobody is doing. Now, in order to bring this uniformity, we inserted this method. And once you got this, that last one, ward-wise land use polygons, then this type of the ward-wise, you can see commercial, institutional, residential, etc. You get this area in hectares. And once you get this, now this is a equivalent area method, which we have inserted. Now idea is that residential area 100% you are going to account. This is human water consumption, and it is assumed that in your school parks 25% of the equivalent area will be in the form of human water consumption, 10% in agriculture industry, open land 0%. So how this human consumption means that people, a floating population, or that a person who is using water in industrial area, not his residential, it is outside his residential. Then you have to multiply this residential area by 125.1, etc. And then you will be, all this you have to do in Excel, very easy. And then you have to project this population density for base year, intermediate, and ultimate stage also. And then you have this shape file. And using that shape file, how this demand is to be given, now I'm going to show you on WaterGEMS. Tea is ready? Okay. We break here. And now this is very interesting, how the demand is given. Then after, my line of action will be, you have given elevations to all the nodes. Now you will be giving all the demands, future, after 30 years demand, to each and every node. Even after 15, the same procedure will have to be adopted. And then run the model. Once you run the model, we will create the DMAs. Everything we will create on your model. That is my objective. And therefore, the idea is how we have to do this actually in our day-to-day design work. Yes. Mic is here. Huh? Okay, it is over, so we go for tea break.